Okay, morning everyone. From the previous lecture, we learned about valence bond theory and hybridization, and we learned how atomic orbital mix to form new hybrid orbital. Today, we want to learn about mode of orbital overlap and type of covalent bonds, sigma and pi bond. Okay, end-to-end overlap will result in sigma bond, and all single bond are sigma bond. And sideway overlap of orbital will result in pi bond. And in terms of strength, pi bond is weaker than sigma bond because sideway overlap is less effective than end-to-end overlap. A double bond consists one sigma bond and one pi bond, while the triple bond consists one sigma bond and two pi bond. Okay, this is how sigma bond is formed by head-on or end-to-end overlap of orbital, and in this region, the electron is concentrated most heavily between nuclei of these two atoms, this region. Okay, here are the example of sigma bond formation in ethane. Okay, look at the electron group arrangement of each center atom C. It has the electron group arrangement is tetrahedral. So the hybrid orbital that involved in center atom is sp3, meaning that 3 sp3 hybrid orbital of each C will overlap with one s orbital of hydrogen, forming 3 sigma bond, and one sp3 of C will overlap with one sp3 of another C to form sigma bond here. A p orbital overlaps side by side, forming pi bond. Okay, here are some facts about pi bond. First, it can never occur alone. It must have sigma bond and can form only if have unhybridized p orbital remaining on atom after form sigma bonds. And pi bonds allow atom to form double and triple bond. Okay, here are the example of double bond formation in ethylene. In ethylene, it has each center atom has 3 sigma bond and 1 pi bond. So the valence orbital for each center atom is here. It has 2 unpaired electrons. Since 3 sigma bond and 1 pi bond needs 4 unpaired electrons, so look at the ground state, it only has 2 unpaired electrons. So it cannot form 3 sigma bond and 1 pi bond. So what we need to do, we need to promote 1 electron from S to empty p orbital here and forming this. Look at the electron group arrangement for each center atom. It is trigonal planar, meaning that the hybrid orbitals that involved in center atom is sp2. So 1s and 2p orbital will mix to form 3 sp2 hybrid orbital and 1 unhybridized p orbital. So 2 sp3 hybrid orbital will overlap with 1 s orbital of hydrogen, forming 2 sigma bond, and 1 sp2 hybrid orbital of C will overlap end to end with another sp2 hybrid orbital of C, forming sigma bond, and this unhybridized p orbital of C will overlap side by side with another unhybridized p orbital of C, forming pi bond. Okay, the sideway overlaps of unhybridized p orbital will result in electron density divided into two regions, above and below line of sigma bond. No electron density along the sigma bond axis, and one pi bond consists of two separate regions of electron density above and below line of sigma bond. Okay, as we can see here, the unhybridized p orbital will overlap side by side, forming pi bond, and uh, sp2 hybrid orbital will overlap end to end, forming the sigma bond, and another sp2 hybrid orbital will overlap with hydrogen with one s orbital to form another 2 sigma bond. Here are some properties of pi bond. It cannot rotate about the double bond, and in order it to rotate, the pi bond must be broken before rotation. Okay, here are the example of triple bond formation in acetylene. As we can see here, each center atom has two sigma bond and two pi bond. The ground state for C atom has two unpaired electrons. Since there are two sigma bond and two pi bond, thus it needs four unpaired electrons. So what we need to do here, one electron from S must be promoted to empty p orbital so that it can have four unpaired electrons. Okay, look at the center atom for C. The electron group arrangement for each C atom is linear, meaning that the hybrid orbital that involved is sp. So one s and one p orbital mix to form two sp hybrid orbital and two unhybridized p orbital. Okay, so one sp hybrid orbital will overlap with one s orbital of hydrogen, and one sp hybrid orbital will overlap with another sp hybrid orbital of C to form one sigma bond, and the two unhybridized p orbital of C will overlap with another unhybridized p orbital of another C, forming two pi bond. Okay, the the unhybridized p orbital will overlap side by side, forming two pi bond. As we can see here, the two unhybridized p orbital of each C will overlap side by side to form two pi bond and result in and each pi bond will has two loops. Okay, double bond is less strong compared to single bond because pi bond is weaker than single bond in terms of overlapping. The side-by-side overlapping in pi bond is less efficient than end-to-end overlapping in sigma bond. In terms of bond order, a double bond is about twice as strong as in single bond, and a triple bond is about 3 times as strong because multiple bonds have greater electron density between the nuclei than single bond do, and thus higher bond energy. So the electron density increase from single bond to double bond and followed by triple bond. Okay, here are the example of question describing the types of bond in molecules. For example, here you need to draw the Lewis structure and determine the electron group arrangement for each center atom. For example, here it is the electron group arrangement is tetrahedral, so the hybrid orbital is sp3, and this trigonal planar, so it is sp2, and O here is trigonal planar, so it is sp2, and here the electron group arrangement for the center atom here is tetrahedral, so the hybrid orbital involved is sp3. As we can see here, there is a double bond, so the unhybridized p orbital from O and C will overlap. The unhybridized p orbital of O and C will overlap side by side to form pi bond. Okay, sigma bond allow free rotation, but pi bond restrict rotation because p orbital must be parallel to each other to overlap most effectively. For example, holding one CH2 group in ethylene and trying to spin the other decrease the side-to-side overlap and break the pi bond. For this reason, cis and trans structure exist for compounds such as dichloroethylene, and the pi bond allow two different arrangement of atoms around the C atom, which has a major effect on molecular polarity. Remember the molecular polarity that we learned from our previous lecture? And rotation around a triple bond is not meaningful since each triple bond C atom is bonded to one other group in a linear arrangement, so there can be no difference in the relative position of the attached group. Okay, according to valence bond theory, the individual atoms, each with own orbital and electron, come together to form bond, and it worries about how atomic orbitals rearrange to form most efficient overlap for bonding. So, in molecular orbital theory, it view molecule as a collection of positive charged nuclei surrounded by electrons occupying a set of molecular orbitals. And it doesn't worry about how atoms come together to form molecules.